Hello, my name is Luke Dietz, and I'm going over my smart doorbell project for ENME435. So here it is right here. So first I'll go over the code. I use some of the functions from the lane detection module, such as masking and thresholding, though it does work somewhat functionally different. The thresholding is more so to detect the change in pixels between two frames captured by the camera. So yeah, that is more or less how the code kind of works. So going into how some of the parameters for it. So the threshold that I found to be the best was about 3,000 pixels. Then there it really shows some sort of movement if it's around there. So it doesn't necessarily pick up too much doesn't pick up noise for detection, but it'll detect something big enough to cause it to go off. I smoothed out the kernel to about 21 by 21, just so that there isn't a whole lot of noise that pops up. And then for the motion delay, I chose about 0.5 seconds so that something can't entirely move past the camera too fast, but doesn't go off so quickly to the point where it is kind of redundant. So for the mask, I made it so that it detects the right side of the camera. So like this area here which you'll see in a minute. And that's because I'm just sitting right here and then the camera's right there. So I don't want to sort of detect it on accident. So I'll put the code on real quick. I use Mimecast for the emails also, but yeah, that's kind of an overview. All right, so it is running. I'm just gonna set these windows up so you can sort of see the difference. This is the delta window, so the changes in the two frames for threshold pixels. And then, where is it? Okay. So yeah, here's the masked image. So it's just the right side of the camera. It is also horizontal right now because of the LiDAR setup, but you can see the two different posters and where that's supposed to capture really in front of this door right here. So where is it? Yeah, so here's the live window. So it's put a blue rectangle where it's supposed to be masking. So I'll do a basic test first. So I'll just put my hand over it like that, and it's going to detect it in the code. As you can see, yeah, detected, recording, takes clip, and then yeah, send email. Email popped up on my phone. Yeah, you can see detected it at the threshold and whatnot. So, yep, and then I'm gonna do something where you can see me in it a little bit. So, let me make these windows better. All right, so I'm gonna stand up. You can't see me because it's, as I said, it's masked. So I'm just gonna be walking, and then when I get into about this area, it should go off. All right, let's see. Did it detect me? It might have picked up my hand. Let me try that again. So as you can see, I accidentally stepped into it again. I'm just trying to get pick up myself real quick. All right. All right, and then here is the door. All right, and I'm gonna walk back out of it. All right, I'm getting the notification. All right, so let's see if it picked it up. Okay. All right, detected my shadow here, I think. And then, yeah, there's my arm, so it picked that up. Yeah. So yeah, that was more or less a demonstration of how it would work. It could be, so this kind of technology could be improved hardware-wise by maybe having different kinds of cameras, like higher quality cameras. This could include infrared technology so that it could better detect changes in light, or it could also include high resolution cameras, so that, because this one is only can detect so accurately, especially in like lighting conditions that aren't that great. Like I have my LEDs turned on, my lights turned on, it still is a little bit inaccurate because it can detect my shadow and whatnot. But I mean, some software improvements though. Some of it might include like a background model or something of that nature. So the background subtractor would work in a way that it would actively detect my background, so it wouldn't just be two different images and the change between them, but the software actively picking up my background and the changes between that. So yeah, that's more or less it. Yeah.